Hello, my dear warriors. Welcome to the Vedantu NEET English channel, and this is none other than your captain speaking. Hello, Baswaraj sir. Nice to see you over here. Hello, Manisha. Hello, Pandu. Hello, Gayatri. Hello, Gautam. Very good evening, Kanishka. Very good evening, Kumar Koran. Hello, Crazy Jude. SL3. Welcome, Krishna. Nice to see all of you, and also the WP hashtag, which is trending. This is the schedule of your amazing NEET Super 6 series. We had an amazing start for this series, and I hope the josh to continue throughout this series. Right now, you can see we have reached the logic gates and devices, a session today. And remember, Diksha ma'am's session has been shifted because of technical difficulties. Her studio is being set up right now to Sunday. Tomorrow you have Gopika ma'am's class, and yes, Baswaraj sir and Gopika ma'am are coming on Christmas with a very special session, obviously of Super 6 for all of you. Okay, so stay tuned for that session as well. And today, like I said, from NCERT and PYQs, my dear warriors, logic gates. Logic gates from NCERT and PYQs. That's all you need. And I'll show you some amazing tricks which you can use in NEET. And I will also use the NCERT back exercise problems. How many of you face difficulty in back exercise? Today we will solve all the problems from the back exercise of logic gates. Are you with me on this? Do let me know. Do let me know by smashing the like button. If you have not yet done that yet, do that right now. And if you have not yet subscribed, subscribe to the channel. Be with your captain. Be with your Shreyas Sir. Be with the Vedantu NEET English channel and the NEET Warrior team in this amazing Super 6 series. And I have been teaching for a very long time, and here I am again for all of you to make sure that you crack this NEET 2024 or 2025 exam, and we are going to be with you till the end. So let's begin with the class with full josh and full energy. Let's get ready. Let's get ready. Nice to see all the Pandus assembled, all the warrior Pandus assembled. Very good. Keep it up. The chat box is warm. It's ripe. Now, imagine you want to communicate between two people, or you want to send some signal. Like, for example, Pandu loves Champa. Champa wants to send a signal to Pandu that I also like Pandu. Like it happens in Pushpa movie, right? You have Rashmika who sends very nice signals to Pandu. Pushpa, sorry. So, the same way Champa wants to send signals to Pandu that she also likes Pandu. So there are many ways in which she can send signals. When she talks, right? Maybe over the phone or maybe on the mic, and maybe Pandu is listening to it. Maybe Champa made a nice reel. Maybe Champa is talking and it is reaching Pandu. So when she is talking, that sound is converted into electrical signal. Sound is converted into electrical signal. Everybody agrees to this? Okay. So now just imagine your sound has been converted into some kind of electrical signal. This is your some kind of electrical signal. This is the electrical signal of the Champa's speech. Now this signal will eventually reach your Pandu. Pandu will be very happy listening to Champa's voice. Now if you see in this signal, the voltage or that current is being passed because it is an electrical signal. That electrical signal can have many values. Maybe this is 0.7 volt, 0.8 volt, 1 volt, 0.8 volt, 0.7 volt, 1 volt, 1.1 volt, 2 volts, 3 volts, 1 volt, 0 volt, negative 1 volt, 2 volt, 1 volt. So you can see there are different levels of voltages or currents. There are different levels of voltages or currents. Such a signal is basically called as an analog signal. Analog signal. Everybody with me on this? Understood? What is the meaning of analog signal? They are basically continuous. They can take many values. 1 volt, 2 volt, 3 volt, anything in between that. They can take analog values. But Champa can also communicate with Pandu in a different way. She uses a torchlight. She uses a torchlight because she can't talk on the phone. Parents are listening, no? Parents are listening, no? So Champa and Pandu, they stay next to each other. Pandu is looking outside the window. Champa is also looking outside the window. Pandu is waiting for Champa's signal. Champa, she takes the torch and Pandu is looking at Champa desperately. And then Champa turns on the torch, turns off the torch. Turns on the torch, turns off the torch. On, off, on, off. So, when she is doing on, off, then maybe again she does off and then she turns on and then maybe she again turns it off, then maybe it's on. Okay, some kind of coded language is there. Off, on, off, on, off, on. Either it is this or that or this or that or this. When such things happen, then it is basically your digital signal. Digital signal. So the best example I gave you was that of the torch, that torchlight, which is being made on or off. Isn't it crazy? So there are two kinds of signal. One is analog signal, one is digital signal. So let's bifurcate that over here. So when you talk about signals, basically signals, there are two kinds of signals. One is your analog signal. The other kind is basically your digital signal. When you talk about analog signals, they look something like this. Like your heartbeat, ECG. When you talk about digital signals, it is either on or then off. Then off. Maybe it is on again, and then off. And then maybe it is on again. So either it is on or off, high or low, 1 or 0, something like that. So this is digital signal. So the examples of analog signals are like your speech signal, right? Or maybe something like your video signal, They are all, analog signals. You can convert it into digital signals also. So there are many examples of digital signals, like the signals which are used in computers. The signals which are used in computers work on something called as ones and zeros. We'll come to that, on digital signals. Computers work on digital signals. Everybody fine till this point? Very good. Nice to see all of you. Gopika ma'am is also here listening to the different signals and Pandu Champa love story. Now here is the thing. Just imagine I want to play with these signals. Why do I want to play with the signals? You will be like, sir, it does not have a better job to play with the other things, but why do you want to play with the signals? See, I might want to do many operations on the signals for doing certain task. When you click a simple mouse button, so many things happen in the background in the computer. When you are measuring, the heartbeat of a patient, do you know that the signals go into some processor and so many operations happen inside that small chip or on that small computer? You are wearing a watch, it is measuring the time, it is measuring how many calories are burned, it is measuring so many things, so many operations are being done at the background, you just don't realize it. So in the computer world, in the digital world, in all the electronic devices around you, in all the small things which are electronically activated or controlled, all these things work on digital signals, and there are many processes that go on, there are many operations that go on. I hope this is very, very clear till this point. Okay, so there are many operations which need to be performed. So when you have digital signals, these signals are given as an input, digital signals are given as an input to something which will operate on it, and it will give some kind of output. A simple example of this could be, imagine there is a tank, and as soon as the water fills till this level, then the motor switch should turn off. You might have seen this device at your home or in your neighbor's home. When the water reaches certain level, tuck, that switch will turn off, the motor will turn off, and no more water is being pumped into the tank. As soon as the level goes down, again the motor turns on, and again the water starts pouring into the tank. So over there, what will be the input? What will be the input, my dear warriors? The level of the water. What will be the operation, my dear warriors? The operation will be, has the level reached this certain level or not? Is it less than that? Is it more than that? That is the operation you will be doing. And if it is more than that, then turn it off. If it is less than that, then turn it on. Are you able to understand? So the output will be whether the motor is turned on or whether it is turned off. As simple as that. As simple as that. So this is the easiest explanation or easiest way to understand what is happening in the digital world by taking a simple example. This thing which does that operation, is called as a logical gate. This is the logical gate. It is some logic, no? The water comes till this level, then you turn off. The water goes below, then turn off. Some logic is there. So it is called logical gate. So a logical gate will have input, and it will do something, and it will give some output. The input in the water example was the level of the water. The operation was to check whether it is more or less, and the output was to turn the motor on and off. As simple as that. So when you click a selfie and when you are typing on the keyboard, there are so many such operations which are happening at the background, at the small chip level. Keep that in mind. So in case of digital signals, what are the different terminologies used in the digital signals? Because I said it could be either this or it could be that. It could be either that or it could be this. So what is that this and that? That is either 0 or 1, high or low. High, oops, what just happened? High or low. True or false. True or false. 0 volt, 5 volt. All these things are the same. 0 means like low, means like false, means like 0 volt. It could be also off, and this could be basically on. All these are digital signals. All these come in the same category, just different ways of writing it. All these things are one and the same thing, just different ways of writing it. So digital signal can be either 0 or low or false or 0 volt or off, or on the other side 1 high, true, 5 volts or on. One and the same thing. Is everybody clear till this point? Is everybody clear till this point? Very good, very good, excellent. So when we have a logic gate, when we have a logical gate, the inputs which will be there, will be 0, 1, true, false, high, low, off, on, right? And the output which will be there, it will be also either 0, 1, high, low, true, false, 0 volt, 5 volt, off, on, like that, right? So it will be either 0 or 1s. And here also input will be 0 or basically 1s. Now, there are so many possible inputs. Like for example, maybe when this input is 0 and this input is 0 and this input is also 0, then the output is maybe 1. Maybe when this is nothing or false, maybe this is true and maybe this is false, maybe then this is 0. Maybe when these both are true and this is false, then maybe this is 1. So what you are trying to do over here is trying to think about all possible scenarios. All possible scenarios of the input. Oh, all of them are false, one of them is false, two of them are false, all of them are true, something like that. So when you pause, try to write down all the possibilities of inputs, and for each input you take down what is the output. Each input, take down what is the output. That thing which you write over here, what is it called, my dear students? What is it called, my dear students? That is called as the truth table. What is it called? Truth table. Very, very important. It happens, no? If you go to the movie and then he also comes for the movie, then I will come for the movie. Then another person is like, no, if he comes for the movie and he doesn't come, then I will go for the movie. If both of them don't come, then only I will come for the movie. So do you see, there are a lot of inputs. These people coming for the movie are inputs. I am going for the movie or not, that is the output. And there is some logical operation happening in my mind. How many of you relate to this example? How many of you have done this while going out? If that cousin is coming, I am not coming. That uncle is coming, I am not coming. He always will ask me my 10th standard marks. He will always insult me. I am not going. Oh, that cousin is coming. Oh, I am coming. 100% I am coming. Oh, but that cousin also coming. Oh, I have to think now. So all these operations happen, and you have been making these truth tables in your mind without realizing. You have been making these truth tables in your mind without realizing. For these things, I will do this. For these things, I won't do this. For these thing and this thing, then I will do this. So you have been making truth tables. You have been making truth tables. Gautam says, no sir, I have not made it. Deepti is relating this. Smiling is also relating this. So many people are relating to this. Thank God, you are normal people. Okay. So I have put up some printed notes also for all of you. You can go through this later on, same things what I wrote, but in a much more, beautiful manner. See, I don't have very good handwriting, just like your biology teachers. So that's the reason why I have also put printed notes. Okay. So signals which vary continuously is called analog. The circuit used for generating analog signal is called an analog circuit. Obviously, if it is generating analog signal, it will be called analog electronic circuit only. This is varying, this is also varying. These are analog signals. Whereas digital signals have two levels, this or that, 0 or 1, true or false. So you can see that digital signals, low, high, 0, 1, true, false, correct? Okay. Logical operations, like I said. So a logical operation will have certain inputs, it will process it, and it will give certain output. Now tell me one thing. In your lower grades, when you are in first standard, second standard, third standard and all that, what did you learn? You first learned numbers? I told you those numbers now. In digital signals, what are those numbers? 0, 1, low, high, true, false, 0, 5 volts, off, on. Then what do you learn? Then you learn addition, subtraction. Then what do you learn? Addition and subtraction, yes or no? How to add numbers, then subtract. Then you learn multiplication. Then you learn, division. And everything and anything in mathematics is based out of this. Be it integration, be it trigonometry, be it binomial, be it logarithm. Everything is a combination of these operations, yes or no? So which are the four basic operations in your regular mathematics? Addition, subtraction, multiplication and division. And then you have equal to. But in logical world, in this logical world, there are some amazing basic operations through which you can make any complex operation. And those operations are none other than, where did it go? Or and not. Or and not, like you have plus, minus, multiplication, division, equal to, all that. So this is or and not. These three basic operations can give rise to any complex operation. What are those operations? We will study. Don't worry about it. So you have something called as the most basic logic gate. You have most basic logic gate. You have the most basic logic gate. You have the most basic logic gate. You have the most basic logic gate. You can have things like this. There is an input here. There is an input here. The output goes to this. This output goes over here. Then maybe this output goes here. Then maybe, one more output comes over here like this. And then this goes over here. And then this goes over here like this. I don't know, some crazy kind of things you can have. And maybe this will go over here, and then this will go over here, and then one more logic gate will come over here like this, and finally the output comes. The output comes here, the input is there. So you can see this is a complex operation, but it has been split into small operations, and these small blocks, the building blocks, the basic logic gates can be either or and not, or and not. These are the basic building blocks. These are the basic building blocks. I hope this is very clear. Any complex operation will always have some basic building blocks. Or, nor, not. Yeah, all these things. Or and not. Correct. Very nice. You guys are understanding this till here. Proud of all of you, my dear warriors. Proud of all of you. So, now that we know that any logical circuit which has input, output and some processing thing, it is made up of either these three elements. Let's start studying them. Let's start studying these basic blocks, and then we'll study some additional gates also. So what is a gate? Gate is an operation. What is a gate? Gate is an operation. Gate is an operation. I just told you right over here. Right over here. Logic gate. It's the logical unit, okay, basic building block right over here. Cool. So let's explain first the OR gate. Champa told Pandu that I will marry you. Champa will marry only if Pandu is rich or intelligent, then Champa marries Pandu. Condition. She has put a condition. So what will she ask Pandu? What will she ask Pandu? Come on, my dear students. Are you rich? Pandu says false or zero or no. Are you intelligent? Pandu says no. Will Champa marry Pandu? Yes or no? Put it in the chat box. Will Champa marry Pandu? Yes or no? Put it up in the chat box. No, right? Is Pandu rich? No. Is Pandu intelligent? No. What the hell is he doing there? False. These two are inputs or outputs? These two are inputs or outputs? Input. What is this? Output. What is the operation? OR operation using the OR gate, OR processing. Correct. Then Champa asks Pandu, are you rich? No. Are you intelligent? Yes. Will Champa marry Pandu? Will Champa marry Pandu? Yes or no? Yes or no? Come on, my dear warriors. Yes or no? Or is there? Are you rich? No. Are you intelligent? Yes. One of them is true. That's it. She will marry. So she will marry. So true. This time, yes. Omar says yes. Suhasini also says yes. K. Suresh also says yes. Very good. Very good. Awesome. Then Champa checks with Pandu. Are you rich? Yes. Are you intelligent? No. Pandu is rich, but he is not intelligent. Champa has put a condition, either rich or intelligent, both, anyone will do. Okay, fine, I will marry you. Okay, fine, she will marry him. Perfect. Then Champa asks Pandu, are you rich? Yes. Are you intelligent? Yes. Will she marry him? Of course. Both are true also. Good. Lottery. This is a lottery only, no, for Champa. This is lottery only, right, for Champa. Very good. So this is OR operation. What have I drawn over here, my dear warriors? What have I drawn over here, my dear warriors? This is the truth table. It is always going to be true. So what is the meaning of truth table? So people think, oh, it's always going to be true. No. Truth table means it tells you when it is going to be true, when it's going to be false. Under what circumstances it's going to be true, what circumstances it's going to be false. Now, when we talk about the OR operation, symbolically how you represent OR is if A is an input, and B is also an input, and the output is, let's say, Y, then the operation which you put over here is plus. I know it looks like your normal mathematical plus where 1 plus 1 is 2, but no, this is your different algebra. This is your logical algebra. So the symbol plus represents what? OR. OR means plus. OR means plus. Keep that in mind. OR means plus. Keep that in mind. Very good. And diagrammatically you show it like this. Oops. Diagrammatically you show it like this. Like this, like this, like this. This is one input. This is another input. This is output. This shape, if it is there, it is OR. This shape, if it is there, it is a OR operation. So I can say here Y is nothing but A plus B. A plus B. Very good. So let's see if you guys can do this correctly or not. Because if I write 0 plus 0, what should be the output? Come on, my dear warriors. It's going to be a truth table now. Truth table scenario. No plus no. False plus false. False or false. Plus should be read as OR. Wherever you see plus, read it as OR. Pronounce it as OR. 0 or 0. 0. No rich, no intelligent, no marriage. Rich but intelligent, marriage will happen. Rich but not intelligent, still marriage will happen. Rich and intelligent, marriage will happen. That's why I told you this plus is not the same as your usual plus. Look at this, 1 plus 1 is not 2. If you write 1 plus 1 is 2, you will get one tight slap in logical algebra. In logical algebra. Be careful. Sounds very strange, no? It is not your usual algebra. 1 plus 1 here means 1 or 1. Oh, this is also true. This is also true. One of them is true. So output is also true. Is this clear? Everybody? Yep. How many inputs can a logic gate have? It can have even more than 2 inputs. But in your NEET physics, you will see only 2 inputs. Okay, when you see proper electronic circuits and all that, it can have even 1000 inputs. 1000 inputs also it can have. No end to that. Very good. So that's how this works. And I have put up the slide for all of you, the truth table, and you know how it is represented in this logic gate algebra, which is also called as Boolean algebra. So Boolean algebra means basically your logic gate operations. Logic gate operations algebra. Logic gate operations algebra on zeros and ones, or trues and false, or no's and yes. That is basically your Boolean algebra. Very good. Awesome. Everybody understood OR? Let's go to AND. Let's go to AND now. So Champa said, if Pandu is rich and intelligent, then Champa marries Pandu. Then Champa marries Pandu. So let's see what happens for such a Champa's condition. If Champa has laid down this condition, she checks Pandu. Is he rich? No. Is he intelligent? No. Will Champa marry Pandu? No, right? He's neither rich nor intelligent. Gone. Now, she checks with Pandu. Are you rich? Pandu says no. Are you intelligent? He says yes. Will Champa marry Pandu or no? Will Champa marry Pandu or no? Come on, put it up in the chat box. And want both the conditions. Yes, Namra, correct. She will not marry. And is there. And means both should be true. Oh, flop show. True and false. She is rich, but he is not intelligent. She will not marry Pandu. Pandu is rich. Pandu is intelligent. Champa says, yes, why not? I will marry you. So that is AND operation. That is AND operation. Very good. Very good. So, my dear warriors, when we talk about AND operation, if A is an input, B is also an input, and the output is Y, the operation that you use over here is a dot. This dot we use in dot product for vectors. They are not vectors. Please don't do that. Okay, they are not vectors. Be careful. And if I show it diagrammatically, you will show a D over here. You will show a D over here. So this is an input A, this is another input B, this is output Y, and this is A dot B. The dot, you will read it as AND. The dot, wherever you see in this Boolean algebra, this logical algebra, you will read it as AND. Let's try this out with all of you with a small truth table. So 0 dot 0 will be how much? 0 dot 0, 0 and 0, 0. 0 and 1 will be how much? It will be 0. 1 and 0 will be how much? It will be 0. 1 and 1, only then it will be 1, that is true or yes or a high, right? That's what it is. 1 stands for high, 0 stands for low. Yep, very good. Excellente, my dear students. Excellente. Proud of all of you. So that is your AND gate. You can see the symbol I have put over here. It is represented by a dot, and this is the truth table. Only when both are true, then it is true. Perfect. Perfect. Now comes the interesting gate. It is a NOT gate. It is a NOT gate. And this happens most of the times with most of you. It's a very funny gate. Trust me on this. If Pandu agrees, then Champa disagrees. If Champa disagrees, and vice versa. Meaning, Pandu says, I will marry you. Champa says, no boss, I will not marry you. Pandu says, I will not marry you. Then Champa says, I will marry you. Mind blown, right? Mind blown, right? And Champa says, Pandu says, I will marry you. Champa is like, no, I won't marry you. Happens in so many movies. Every time the hero is after the heroine. Heroine will be like, no, 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 no. Then some climax interval scene happens. Then the hero gets very angry. He goes off. Then the heroine goes behind the hero. And then heroine is saying, I want to marry you. Hero says, no, I don't want to marry you. Always. Most of the movie plots are like this only. So this is basically your NOT gate. This is basically your NOT gate. So how do I show this NOT operation? Let's have a look at it. This is NOT, NOT. When you want to show the NOT operation, the input that you have and the output that you have. You have one input and one output, remember, because one input, one output, not two inputs, one output. So the operation that you show over here is a bar. A bar. It's not a vector. Don't think, sir, vector becomes scalar, sir. Legendary people. Legendary people only will say that. Those who have not attended the previous parts. A bar, sir, vector becomes scalar. No, this is A bar. This is not of A. Whenever you see the dash, read it as not. Whenever you see the bar, read it as not of that thing. Okay, so how do I show it symbolically? You put a triangle over here with a dot over here like this. If this is the input A, this is the output Y, this Y is basically A bar. Y is basically A bar. Yep. Are they following the basis of logic gates? Yes. See, this is what happens. Even movies use logic gates. Nobody knew this. So, just to give you an example, 0 bar will be how much? 0 bar will be how much? Let's see how many of you can answer this quickly in the chat box. Quickly in the chat box. Yes, 0 bar will be 1. Very good, my dear warriors. 1 bar will be not of 1, not of 1. 1 is yes. The not of yes will be no. The not of 1 will be 0. Very good. What about 0 bar bar? 0 bar bar. 0 bar bar. Come on, my dear students. 0 bar bar. 0 bar bar. 0 bar is 1. 1 bar is 0. So 0 bar bar is 0. Very good. 1 bar bar. 1 bar bar. 1 bar bar. 1 bar bar will be 1 because 1 bar is 0. Not of that will be again 1. So 1 bar bar will be 1. Very good. Isn't it funny? Isn't it interesting? So simple. So I put that up on the next slide. 0 is 1. 1 is 0 for not. It is represented by a bar. The triangle with that, that circle should be there. The triangle with that circle should be there to represent it in the logical circuit. To represent it in the logical circuit. But there is something more. There is NOR gate, there is NAND gate, and so many things. So it is just an extension of the previous one. Let's have a look at it. But before that, one simple thing. Sir, I always get confused, sir. OR, NAND, or NOT. The symbols are very confusing. No issues at all. Let's try this out by Captain Shreyas Sir's method, and after learning this trick, I want the hashtag WP trending. So, when you talk about AND gate, okay, AND gate, right? So, let's write it down. And this is how it looks like. Don't you see? I can just add over here A, N, and this D, A, N, and do you see that D over there? That's it. That is the AND gate. Cool? Simple? Okay. Let's try for OR gate. Let's try for OR gate. Okay. So for OR gate, something like this, like this, like this. Okay. No issues. Like this. So what I do, I'll just write over here. Do you see? It feels as if somebody has eaten something. Some apple has been eaten or something. So that remaining part, I'll just show over here and then just over here, OR gate, OR gate, perfect, awesome. Next, NOT gate, right? NOT gate. Okay, let's do this. Okay, just 1 second. Let me use this one. Oops, this triangle right over here, and this, yeah, this right over here. So for NOT gate, we have this O, right? This dot, this circle, right? That's it. Now think over here, what will I do? I'll write N-O-T, not. That dot or that circle becomes that O. That's the easy way or trick to remember it. So now start trending WP. Mind blown, Ramya? Very good. Very good. Krishna is already so happy. Very good, Pandu. Thank you so much for trending that. Bar hoka. Oh ho. Entertainment TV. No wonder your name is Entertainment. Hookah bar, hookah bar. Yeah, some Bollywood song it is. Correct. Now, let's go to NOR. By looking at a NOR gate, what is the idea that you get? NOR, N, not, OR, OR. Oh, not and OR is NOR. Not and OR is NOR. Like it happens, right? Virat Kohli married Anushka Sharma. And then they made a new trending name for the couple and they called them Virushka. So Virat plus Anushka became what? Virat plus Anushka became what? Virushka. So many other couples and celebrities who get married, they find a nice combined name. So the marriage between NOT gate and the OR gate is basically the NOR gate. How do you show it? You show the OR gate normally. Remember, OR gate always has that curved line. In front of it, don't draw the line, just put a circle. That's it, it becomes a NOR gate. As simple as that. Very good. So how could the truth table look like? This is how it looks like. So say for example, this is the input, this is the output. First of all, that Y will be, think about it carefully, OR operation you will perform A plus B. A plus B means A or B, but you have to negate it, you have to not it, you have to flip it, you have to invert it. So you put a bar over the entire expression. That becomes a NOR gate. How many of you got this? I'll repeat. What is A plus B? A or B. If I put bar, what happens? Whatever is there inside becomes opposite, inverts, flips, knotted. So A or B, not NOR gate. As simple as that. Got it? Very good. So how will the truth table look like? Let's draw that. So you have A, you have B, and here you have basically Y, which is your output. Say for example, A is 0 or A is false, B is false. What do you think the output will be? Whatever you are expecting for OR, exactly opposite of that. A or B, false or false is a false. So negate that. So it will be basically true. Very good. Understood? Again, false nor true. So first do the OR operation in your mind. False or true. One of them is true. So the output will be true. But you have to negate it. So you will make it false. Then if this is true, this is false. True or false, one of them is true. Output is true. But you have to negate that. So you have to make it opposite and make it false. Both of them are true. True or true is a true. But you have to negate it, not it. So that's why it will be a false again. Is that clear? So that's why 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0. That's how the output will look like. Yes, the quizzes will come. The quizzes are coming. And we have NCERT back exercise completely solved over here. Not just that, PYQs of all the years which have been asked. Guaranteed one question from logic gates. Because you have attended today's class, your 4 marks out of 720 are there. Sir, 4 marks, so lesser. 4 marks will decide whether you get the government college or not. 4 marks will decide whether you will repeat or not. 4 marks will decide whether you will leave the city or whether you will stay in the city. So don't ignore the small marks. Yep. So that is your NOR gate. OR plus NOT is a NOR, A plus B bar. Here is the truth table. They have put an intermediate step just to show what is OR, and then they have negated it. Whatever you expect for OR, this is NOR. So this is basically your OR operation. This is basically your NOR operation. Okay. Same thing, whatever I explained is there on the beautifully printed slide. Okay. So that is NOR gate for all of you, right? Now let's go to NAND gate. Whose marriage happened? Come on, let's see who can guess this. Virushka. Virushka is Virat plus Anushka. NOR is not plus OR. NAND is the marriage of which two people? Think logically, no? NAND is the marriage of which two people? NAND is the marriage of which two people? Sir, is this not for JEE? You can watch it for JEE also. Very good, crazy dude. Perfect. Not an and, not an and, not an and not, whatever you want to call. Yes. So the marriage of NOT gate and AND gate gives you the NAND gate. Gives you the NAND gate. Correct. So NOT gate is basically this. AND gate is basically that D. The NAND gate, you put the D but with a circle. Put the D with a circle. Whenever you put the circle, it is NOT operation. How will I show it mathematically? Oops, I forgot the other line. My bad. Yeah. So how will I show the mathematical operation? If this is A, this is B, this is the output Y. The output Y will be, you first do the AND of both of them. So A and means dot, B. A and B. But you have to flip it, negate it, invert it, not it. Not means bar. A dot B bar. Is that clear? Is that clear? Very, very, very good. Amazing, amazing, amazing warriors. All the Pandu warriors are doing it extremely well. So let's try this out. Let's try this out. This is A, this is B. This will be A dot B, but what I want is A dot B bar. Okay, so let's try this out. Come on. So for all the possibilities, the truth table, 0, 0, 0 and 0, 0. The negation of that, 1. 1, 0, true, false, false. The negation of that, true. False, true. 0 and 1, 0. Negation of that, 1. 1 and 1 is 1. True and true is true. The negation of that is a false. So this is the truth table. This is the truth table. How many of you understood this clearly now? Is there any confusion? I don't think so. Because when Shreyas Sir teaches, there is no confusion. When Shreyas Sir lecture, you attend, you understand it in and out. When Shreyas Sir teaches, Shreyas Sir goes from the basics, so that even if right now a 6th standard student is also watching this class, that student will also be like, oh my God, is Shreyas Sir teaching for 12th standard? Who are these elder people who are sitting with me? They don't understand this. I'm in 6th standard and attending it. I'm not kidding about this. There have been, these kids, no. There have been kids who have been watching me from 6th standard, 8th standard, and now they have come to 11th standard. Sir, you know what? I used to watch it when I was in 6th and 7th standard. Hey, macha, what? Nicely you are attending the class of 11th standard sitting in 6th and 7th standard. You must be showing off in front of your friends. Yes, sir. How do you know? Now what are you doing with me right now in 11th standard? Sir, again I want to learn from you. Are you already learned from me? No, sir. Again I will learn from you. Again I will revise from you. And then that student went into IIT. That's how it is. Or AIMS. So that is your NAND gate for all of you. I put the beautiful printed slides. Beautiful printed slides for all of you. Now what is this XOR? Like, sir, what is this X, sir? What is this XOR, sir? This is crazy. Whose marriage is this? Whose marriage it is? XOR. I don't know who is X. Is it my ex-girlfriend, sir? Is it my ex-boyfriend, sir? No, it is not your ex-girlfriend or boyfriend. XOR is exclusive OR. Exclusive OR is XOR. Exclusive OR. This question may not come, but still, I'll just tell you for the sake of it. For the sake of it. So what is it? So what is it? This is a very interesting one. You see this. If Pandu is rich XOR intelligent Champa marries Pandu. Now you will be like, sir, what is this, sir? See, Champa has become very smart. She realized one thing. That if Pandu is not rich and Pandu is not even intelligent, then there is no point only to marry Pandu. So she says no to the marriage. Pandu is just rich, okay, but not intelligent. Okay, he has a lot of money, no problem. I will marry you, no problem. She sees Pandu is not rich, no problem, but he's intelligent. He's intelligent, he's smart, he will do well in life later on. She has that thought process, very smart she is. So she is like, okay, I'll marry you, or at least intelligent. No, I know you will do very good in life. Then she sees one Pandu who is rich as well as intelligent. He is rich and intelligent. 100% he will be a show off. He'll full on, show off. He will have lot of attitude. Get lost. False. Yeah, Pandu got married and remarried and unmarried. How many times today in this class? I don't know. So many marriages happened for Pandu. So this is a very smart Champa, I would say. She knows that this person will have too much attitude. So this is exclusive OR means only one of them should be true, others should be false. Exclusively true, exclusively false. Both are the same, I will not accept. That is XOR. Is that clear? Everybody with me? So exclusively OR. When both inputs are false or both are true, then a false output will come. If one of them is true, then the output will be a true. The symbol for that is this. The symbol for that, I'll just put it over here. The symbol for that, you use the usual OR symbol. Remember that curved line like this. You put just one more curved line with this. That is your XOR gate. So this is A, this is B, this is Y. Usually for your OR operation, which symbol do you use? Plus, right? But for XOR, you put a circle. Over it. That's all. That circle over that plus means it is exclusively OR. That is your XOR. 0, 0, 0. 0, 1, 1. 1, 0, 1. 1, 1, 0. Both can't be the same thing. Both are the same thing. False. One of them is different. That's it. It is output is 1. Very good. Now, this thing, no board teacher will teach you. They will be like, draw a truth table and all that. But you are preparing for NEET, not just for boards. And believe me, this is a hidden trick, which very few people know. I know it because I studied electronics and all that. So yes, my dear warriors, your captain is very experienced. Okay, so I'm going to teach you a trick which is called as your De Morgan's theorem or De Morgan's law, and that will help you solve the NCERT problems as well as the PYQ problems in a very simple way, which you can apply it in NEET and save a lot of time. So what is this De Morgan's law? Let's have a look at it. And what is this De Morgan's law? It is nothing but if you have A, B, if I put a plus over here and I put a roof on both of them, I put a bar on both of them, then according to De Morgan, what happens is that plus can be converted into a dot. And this roof, this bar which was there on both of them now will be divided. It will be separate. This will be A bar dot B bar. That is the first De Morgan's principle. If you want to have a look at it diagrammatically, then A plus B, that is A or B. So A or B, or A or B, right? Bar, that means I put a not over here. that means I put a not over here, that is this one, is equal to a bar dot b bar. A bar will be like this and b bar will also be like this, and you dot them, that means you put and symbol over here. That's what this is. So this is same as this. Here it is or and here it is and. So you put the dot before or you put the dots before the and, one and the same thing. Okay, that's the first important principle or law or theorem. The second is exactly opposite of this. So if you have a dot b bar, that will be, come on, let's see how many of you can write this down logically. Get the hint, get the idea from here and guess the output. A dot b bar will be, yes, this is in computer science, correct? I have studied computer science also. Yeah. I've done a lot of things. So a dot b bar is, let's see how many of you can answer this correctly. Logical Pandu warriors, logical warrior Pandus, come on. What should it be? Exactly. A bar plus b bar. Dot replaced by plus. Dot replaced by plus. And that roof, that bar, separate it out on A and B separately. If I want to show the diagrammatic representation of this, A dot B bar, A dot B is AND. So I show a AND gate. And because there is a bar, bar means not. So this is this LHS. This is the left hand side. What about the RHS? A bar. This is A bar, NOT gate. B bar. This is again that another NOT gate. They are both getting ORed. That means I show a OR gate over here and this is the final output. That's the same as this. This can be replaced with this. This can be replaced with this. That's all. Use this second theorem and the first theorem wherever you can, specifically for NEET. For boards it is not there, but you will have to do it via the truth table and stuff like that. But for NEET, I am teaching you this shortcut trick. Keep this in mind. Are you now ready for the questions? Ready? Are you now ready? Sir, I'm Kirito's brother. Oh my God, who is this? Ananta Gutta. Oh my God, Kirito was one famous kid in my class in Vedantu JE English. Right now also I am there. I'm back over there. So Kirito, one of my favorite, always, all the YouTube classes, Kirito. And he used to come up with fancy names. Wow, and we have the brother too. Crazy. Amazing. So I hope many more Kiritos, many more Pandus, many more warriors are produced from this channel too. Chalo, let's begin then with the first question coming up. This is from your NCERT back exercise. Okay, 14.15. All the questions we are solving. You are given two circuits as shown. Shown circuit A as an OR gate. Show that the other circuit acts like an AND gate. Show. Okay, in the NEET exam, what will come? This gate is behaving like OR, NAND, NOR, NOT, etc. Options will be there. Here it is coming like a proof. No problem, we'll do it. So, my dear students, do you see the first diagram? Which gate is this? Which gate is this? First answer that in the chat box. Which gate is this? You can see the curved one line with a dot. So 100% it is a NOR gate. What is this? This is a NOT gate. Now when I say NOR means OR and a NOT gate, OR and a NOT gate, and this NOT gate is as it is. So I have just split it up into two parts. Now what will happen when you combine two NOT gates together? When you combine two NOT gates together, nothing will happen. It will be just a simple, input is output. 0 is 0, 1 is 1. Right? 2 bars, 0 bar, 0. 1 bar, 1. It's the same thing. Whatever comes in, that same thing goes out. Basically nothing happens. Nothing happens over here. Nothing happens over here. What is left? Only OR gate is left. So hence the final answer will be, it is a OR gate. That is the correct answer. The final answer is, it is nothing but an OR gate, which is exactly what you had to prove. Is this Problem clear, they will cancel out, perfect. Let's do the second problem. You have to show that this is an AND gate. I think if you are smart, you will get this answer very quickly. Try to think what operation is happening over here. This is A, this is going to be A bar, NOT gate is there. This is B, so this will be B bar. This is OR and a NOT gate. OR and a NOT gate, that means it is a NOR gate which is there. NOR gate which is there, correct? Okay, so observe this, what I am going to do. NOR means OR plus NOT. You have to use a plus symbol and then a bar symbol. So I will take the input, the first input is A bar, the second input is B bar. What should I put over here? Plus symbol. Why plus symbol? Because there is OR and the NOT of it. So I'll put a big bar over them. I'll put a big bar over them. This whole circuit, if I write it mathematically, it will be like this. This whole circuit in a simplified form will look like this. Yes or no? How many of you got it? Very good. Now observe carefully. Do I know De Morgan's theorem? Yes. Can I use it? Yes. For NEET, definitely I will use it because it will save me a lot of time. Lot of students try to do the same problem via truth table. A bar, B bar, A bar plus B bar, then A bar plus B bars bar, 0, 0, 0, 1, 1, 0, 1, 1, this is 1, this is 1, this is 0, this is 0, this is 1, this is 0, this is 1, this is 0. Then you start solving it. Then you see, oh, this is the final truth table. Is it AND or? Very lengthy. This is lengthy method. You can use this in boards, but not with NEET. In NEET, you have very little time. So what will you do? When there is a plus, what do you do? When there is a plus, what do? You convert it into a dot. So A bar dot B bar. A bar dot B bar, and that big bar which was there, you split it into two bars. That big bar which was there, you split it into two bars, correct? I have used it as De Morgan's theorem. What is A bar bar? A bar bar is A. What is B bar bar? B bar bar is B. So that dot symbol remains as it is. So this is an AND gate, which is exactly what was needed. Isn't it simple? Isn't it simple? I'll just repeat what we just did over here again. What we did over here again. Okay. What are the inputs for this gate? What are the inputs for this gate? A bar and B bar. What are you doing? NOR. NOR means OR and a NOT. OR means plus. And the NOT of it means bar. So that's why this whole thing is this one. With little bit practice of today's session, you will get to know how to write it in a mathematical form. And then writing this, simplifying it is a very simple process. Understood Medico 2024, how to do this? Understood this? This is an NCERT problem, back exercise problem. I am solving it for you. This can most likely come in NEET examination. Simple, Alam? Okay. Chalo, we will do more practice, guys. So many practice problems are there for you today. After this, you dare say I don't understand logic gates. It is impossible. Now, this question is very important. 14.16 NCERT back exercise. There is an AND gate and both the inputs are connected, joined together to input. And you can see there is a NOT over here. That means it's a NAND gate and that output is there. Question is, write the truth table for the gate given. Okay, we'll do it normally and then I'll show it to you otherwise for NEET also. Write the truth table. So A is there. So what will be the inputs? What will be the inputs? Oops. What will be the inputs? And then what will I get as the output, which is basically a NAND gate. So first let's see what we get for AND, and then we get for Y, which is a NAND gate, which is a NAND gate. Okay, let's try this out. Let's try this out. Okay, A is 0, that is one possibility. A is 1. These are the only two possibilities, yes or no. A can be 0 or it can be 1. If A is 0, that same 0 will go here and here. So the inputs will be 0, 0. If it is 1, the same 1 will go as the inputs 1, 1. Now 0 and 0 will be how much? 0 and 0. Pandu is neither rich, Pandu is neither intelligent. Champa says no marriage, so 0. Pandu is rich, Pandu is intelligent. Pandu is rich and intelligent. Champa will marry Pandu. NAND means you have to negate it. So if it is 0, you will make it 1. If it is 1, you will make it 0. So my dear students, only consider this as the input and then see this as the output and then comment below what gate is it looking like. From here to here, what operation is happening? I think it is a NOT operation which is happening. So if it is 0, it is 1. If it is 1, it is 0. So it's a NOT operation. So this diagram, can I say, is as good as this diagram? As good as this diagram? As good as this diagram? Very good. Excelente. So my point is that you can use this as a trick. Write this in your short notes. Wherever you are making notes, write this in your short notes. What will you write in the short notes? If just like over here, this was a NAND gate. If you take a NAND gate, or you can also take a NOR gate. That's also okay. That's also okay. And what you do is short the inputs. That means connect the same input to both the ends. Then that gate basically behaves like. What gate? A NOT gate. Then that gate behaves like a NOT gate. This gate behaves like a NOT gate. Whether it is NAND or NOR does not matter. Whether it is NAND gate or a NOR gate doesn't matter. It will behave like a NOT gate if both the inputs are connected. So when you connect the inputs, that is called as shorting. Shorting means you are connecting them together. That is the meaning of that. Very good. Also, you should know one more thing. See, using NAND, I was able to make NOT. Using NAND, I was able to make NOT. Using NOR also, I was able to make NOT. In fact, it is found that using NAND and using NAND or basically even NOR gates, you can make a NOT gate, you can make even a AND gate, you can make even a OR gate, you can make even XOR gate, etc. Whatever gate you want, you can make it. That's the reason why NAND, NOR, both of them are called as universal gates. Universal gates. Using some combinations, you can make any possible gates. That's why they are called as universal gates. Is that clear? Yes. Glad, Krishna. I'm so glad that you guys are enjoying the NCERT questions. 2. Shall we continue this for all the other chapters also, starting with high weightage, obviously, with the 11th standard and then the 12th standard also. But for 11th standard, right now, many students would have forgotten that NCERT. So it will be beneficial for you to actually go through those problems through these lectures, right? So for 12th standard, anyways, it will be useful for your upcoming boards. For 11th standard, it will be a very good revision for many students, and for specifically 11th standard, it will be helpful for your 11th standard boards or school college examinations. Correct. So let's do the next question. 2 circuits are given which consists of NAND gate. NAND gate. Identify the logical operation carried forward. Okay, use my trick. See if you can find either this or this. Either this or this somewhere. The moment you find either this or this, write it as a NOT. Write it as a NOT. That's it. It will become very, very simple, guys. This is your NCERT 14.17 question. Can you see something? Can you see something? Look at this. NAND is shorted. NAND is shorted. Do you see that? So what will this become? What will this become? Come on, answer in the chat box. How many of you saw that? Very good. Yes, this is nothing but a NOT gate. So now this was an AND with a circle. So this is a NAND gate. But a NAND gate is actually AND gate with a NOT gate. This NOT will come as it is over here. Now, when you have two NOT gates together, what will happen? It will just become nothing. Nothing as it is will go out. So what is remaining is just a simple AND gate. So AND gate is the answer to this. AND gate is the answer to the first problem of 14.17. Is that clear? Null? Yes, very good. Can we similarly do this question? Can we similarly do this question? Can you see some part of the circuit which is actually a simple circuit which can be converted into some other gate? I think you can. I think you can. I believe the one over here and the one over here, both of them are NOT gates. Both of them are NOT gates. Correct? So technically, if this is A, this is B, what will be this point? This point will be A bar. What will be this point? This point will be B bar. Okay. Now I can't do by the same technique because it is not so simple as this one. I will think logically. The inputs, so A bar and B bar are basically the inputs to which gate? To which gate? The NAND gate. To the NAND gate. And that's when you get the output Y. So here is my solution. See how I'll do it. I will not do by this method because it will be quite complex, right? To understand it that way. Here, I will do something which I used some time back, the De Morgan's principle. Inputs are A bar and B bar. A bar and B bar. And what am I doing? NANDing it. That means I am first ANDing it. I am doing AND operation, that means dot, and then I am NOTing it. See again, A bar, B bar are the inputs. I am first ANDing it, that means I am first putting a dot, and then I am putting NOT over both of them. So that's why this bar symbol. Is this first step clear? Then write clear. Yes, let's use De Morgan now. Shall we use De Morgan now? Okay, what does De Morgan say? He says that if you have two things and you are doing some operation, that's change the sign first, the dot will become plus. What are those two things you are operating on? A bar and B bar. Then the big bar which was there, you split it up into two small bars. Split it up into two small bars. Now what is this? A bar bar is A. B bar bar is B. What is A plus B? It is basically a OR gate. Wow, we got the answer. We got the answer, my dear students. Isn't it simple? Haven't I made it very easy peasy? If you do a truth table, you will take a lot of time. Like see, if you do a truth table, first of all, if you don't know this is a NOT, then to gone. All the best solving this problem. If you don't know this is a NOT, it will take even more time to solve it. Then you should know, okay, this is A bar. Okay, then there is B, then there is B bar. Then there is A bar dot B bar, and then there is A bar dot B bar's bar. So imagine all the combinations 0, 0, 0, 1, 1, 0, 1, 1, and writing all these things. It is very lengthy method, useful in boards, but not in NEET. In NEET, you have to think differently. So many students ask me, sir, I am preparing very well for boards, but I don't get marks in NEET. This is the reason. And not just in this chapter, every chapter this happens. Now did you understand why you need to prepare for NEET exclusively, not just boards? Only boards if you study, you might not be learning the best things. You might not be learning the shortcut tricks. You might not be learning some innovative techniques. Remember that. Okay, let's go to the next question coming up on your screen. 14.18 exercise of your NCERT. Yes, truth table will consume a lot of time, Alam. So if you have only one NOT gate, we can use the first method. Yes, then use the first method. When there are more than one NOTs, no, then usually go for De Morgan's theorem. Yes. How you concluded that A bar and B bar? Where? Here? How I concluded that A bar? Because this is A, this is NOT. NOT means A bar. Because this is a NOT gate. How do I know this is a NOT gate? I explained it right over here. Whenever a NAND gate is shorted, then it becomes a NOT gate. And for that also, I did this problem. So it's all linked, interlinked with each other. Okay. So if you solve one problem, you get the next problem. Cool. Okay. Chalo, let's try to do this. Question coming up on your screen. What is happening? This is a NOR gate which is shorted. A NOR which is shorted, will be a NOT gate. You can see it is shorted. So 100% this is a NOT gate. And what is this? Okay, this is a OR with a NOT. So this is NOR gate. NOR is basically OR with a NOT gate. And this thing was a NOT gate. Correct? This thing was just a simple NOT gate. Two knots together will do nothing. So only this gets carried forward, and hence it is a OR gate. Here I did not use De Morgan's theorem. Why? Because I didn't see bar over here, A bar, B bar, or something like that. If you see in this problem, I saw A bar and B bar, and then something is happening with that. That's where I used De Morgan. Otherwise, don't use De Morgan. Here we didn't use. Clear? Oh, can we move ahead to the next part? Very good. Let's move ahead. Yes. Here comes the next question. This question is the same thing. The hint was given here. I didn't want you to see the hint. Without the hint only, we have solved it. Okay. 14.19. Write the truth table for the given circuit below consisting of NOR gates. Identify the logical operation performed. This is very simple. What is this going to be? Think about it. If A is going over here, as 0, both the ends will be 0 and 0. If A is going as 1, both the ends will be 1 and 1. ORing it means 0, 0. If I OR it, 0 or 0 will be 0, 1 or 1 will be 1, but then I have put a dot. That means I have NORed it. So if it is 0, it is 1. If it is 1, it is 0. So if you look at this and this, it is very obvious. I have knotted them. 0 becomes 1, 1 becomes 0. It's a NOT gate. So it's a NOT gate. That's the first answer. Everybody has written it down. Very good, Omar Alam. Yes, Shangmugam. Very good, Shubhanshi. Very good, Crazy Dude. Lakshmital, Nilesh, Gayatri, Banot. Very good, Vishnu. Very good, Shanmugam. Very good, Imedi. Very good, Sanvi, Nilesh. Awesome, my dear students. Let's go to the next problem. Oh, I don't know why they gave this as A bar. I mean, this was not supposed to be given in NCERT, but yeah, anyways. I know that NOR gate is shorted. So anyways, both of them are NOT gates. So A became A bar, B became B bar. When you short a NOR or a NAND gate, it becomes a NOT gate. Okay, I think I should use De Morgan now. Everybody, come on, get your pens ready in the rough work. See if you are able to write the logical expression, because this is a NOR gate. You are NORing A bar and B bar, which are basically your inputs. These are basically your inputs, A bar and B bar. You are NORing it. NORing it means you first put a plus. Which are the inputs? A bar as well as B bar. They are the inputs. You first ORed it. You did OR and then you did a NOT over it. That is the NORing operation. This is first input, second input, you do OR and then you put the NOT symbol. Now use De Morgan's principle or theorem. Whenever there is a plus, you put a dot. What are the inputs? A bar as well as B bar. That big roof that you see over here, you split it up on both of them. So A bar bar A, B bar bar B. So what is this? AND gate. Correct. That is the answer. Very good. Proud of all of you. Shall we go ahead? Next question. We have started with PYQs. We have completed all the back exercise questions. All the back exercise questions are done, my dear students. Are you now ready for PYQs? Will you be able to do it after doing NCERT and Shreyas Sir's class and explanations and all the solved examples which we did in the class? Are you capable of that or no? I think so. You are. Yes, let's do it. Lakshmita saying WP, WP. All the warrior Pandus whistle Bodu. Come on, let's do the first question. NEET 2020. For the logical circuit. Shown the truth table is. Very tricky. Different kind of question, right? So let's see. What is happening over here? What is happening over here? If this is A, this is a NOT gate. This is a NOT gate. This is also a NOT gate. So A bar, this will be A bar. This will be B bar. What is this? OR with a NOT. So this is NOR gate. Okay. So inputs are A bar, B bar. Inputs are A bar, B bar. Inputs are A bar, B bar. I first do OR operation. That means I put plus symbol. OR operation means plus symbol. And then I put a big bar because of this N. I put a big bar because of this N. Everybody clear? According to De Morgan, what will happen? Whatever inputs I took, A bar, B bar, instead of doing plus, I will now have to put dot. Instead of plus, I have to put a dot. And this big bar will split into two small bars. Big bar will split into two small bars. What is this? A, B. What is this? AND. We know the truth table for AND. We know the truth table for AND. Is it C for capto? Is it C for capto? Yes, it is. 1, 1, 1. All other things will be 0. Isn't it simple? If you do by the layman techniques which many other teachers might try to teach you, some crazy thing. Try everything. A 0. This is 1. This is 0. This is 1. This is 1. This is 0. This is 1. This is 0. 0, 0. 1, 0. 0, 1. 1, 1. Then you take the OR operation. Then you negate it. In that time, I will have a haircut and come back. And also drink some juice. And also take a nap. And then I will come and still you will be doing it. Don't do by such lengthy techniques. Use Captain Shreyas Sir's WP techniques. Correct. C for capto, C for champa. Oh my God. Okay, chalo, let's do this. The correct Boolean operation represented in the circuit. This is tricky. This came in 2019. See, don't expect whatever you study in NCERT directly will come. You have to think in the exam. That's what they are checking. That's why you should solve PYQs. Only NCERT won't help. You have to solve PYQs also. That's where you understand what is the level of questions that they can ask. Now, in order to solve this question, I will give you a precursor. I will give you a nice example and see whether you guys are able to understand this. Imagine there is a circuit and there is a switch. There is a switch again, okay, like this. And maybe there is a bulb over here. There is a bulb over here and there is a battery. And there is a battery. Okay. This is input A, this is output, input B, and the output is Y. These are switches. Now think about the truth table. Think about the truth table. How will it be? If for example, A is off, B is also off. What will happen? Is the circuit going to be complete? No, right? Will the bulb glow? No, right? So the bulb won't glow. Let's say one of the switch is closed, but still B is open. The circuit is still not complete. If this is closed, this is open, still the bulb won't glow. The bulb won't glow. If I open A, but B is closed, still there is a gap. The circuit is not complete. Still the bulb won't glow. Only when both the switches are closed, only then the bulb will glow. What kind of gate is this? Isn't this an AND gate? Isn't this an AND gate? Very good. Now, similarly, just imagine this. There is a switch here. There is a switch here. And this is connected to that bulb. Okay. There is a battery here. And this I call as A, this as B. This is the output Y. So A, B, Y. Just try this out. What do you think will happen now? If A is open and B is also open, the circuit cannot be completed, no current will flow, the bulb will not glow. The bulb will not glow. If A is closed, B is open. A is closed, B is open, the circuit is complete, the current can flow from A, so bulb will glow. If A is open, B is closed, the current will flow via B, and you will see the bulb will glow. If A and B both are closed, then it has both the options, it will come back and the bulb will anyways glow. So isn't this a OR gate, my dear warriors? Isn't this the OR gate, my warriors? So these kind of things can be done with switches also. So now similarly think, which kind of gate is this? How will the current flow? Will the current flow or not? Just try to think about it. Make a truth table if you want to. Okay, so let's make a truth table. A, B, and whatever is that output, Y. Okay, so let's try to do this. Imagine both are closed. Imagine both are closed. This is 6 volt, this is ground. Think of this as if there is a battery connected here. Think of this as if there is a battery connected over here. Forget this, forget that 6 volt. This is positive, this is negative. Is the circuit complete? Yes or no? Is the circuit complete? Yes or no? Just answer, come on, my dear warriors. Will the bulb glow or no? What has this got to do with anything? Nothing. The current will go like this. No current will go here. No current will go here. So definitely the current will continue going in this bulb. 100% it will glow. 100% it will glow. Everybody with me on this? Very nice. Now, this is open, this is closed. This is open, this is closed. What will happen? Can the battery supply the current here? No. If it can't supply the current here, it can't even go here. So even if B is closed, if A is open, this part of the circuit is still disconnected. So the current will continue going in the bulb. The current will continue going in the bulb will glow. If A is closed, B is open. A is closed, B is open. Still this part of the circuit is disconnected, because if this is open, that's it. There is no connection. This part cannot have current. All the current will go through the bulb. So the bulb will glow. But if both are closed, this is a simple wire. The current will have two options, go from here or go from here. When it sees this path, it has some resistance. But when it sees this path, it has no resistance. The current, when it goes here, it sees this path and this path. This path has so much resistance. This path has no resistance. So all the current will go from here. No current will go from the bulb. It will not glow. It will not glow. So which gate is this? Which gate is this? Obviously a NAND gate. Because we know this is AND operation. AND operation would have been no, 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 yes. So this has to be exactly opposite of that. Exactly opposite of that. 100%. Cool. Let's go ahead to the next PYQ coming up on the screen right now. If you answer this 2016 question, I will be very, very happy. To get output as 1, which combination will work? I'll tell you the best way to solve this. Actually try all the options simply. Don't use any other method, De Morgan, nothing. Just actually try it out. You will get it. Come on, everyone, try this out. Everybody try this out. For getting the output as 1, which of the options will work? Try it. 0, 1, 0. Just try it out. 0, 1, 0. 0 and 1. 0 and 1, what will you get? You will get 0. This 0 will come over here only. As it is, will come over here. 0 and 0. 0 and 0 will be a 0. But there is a not over here. So what will the output be? What will the output be? It will be basically 1. Are you seeing that, everyone with me? Are you seeing that? Everybody with me? Yes. The correct choice for the input to get the output. Yes. So 0, 1 is going to give me 0, and 0 with 0 is 0, but the not of that is basically 1. So with A option I am getting it. With A option I am getting it. What about other options, my dear warriors? What about other options? Just try this out. 1, 0, 0. 1, 0, 0. 1, 0, 0. Just try this out. 1 and 0, 0. This 0 goes here. 0, 0. This 0, 0 and if you do it will be 0. The not of that will be 1. Again I am getting 1. Is this something wrong in this? I think it was incorrect question or something, or incorrect option. Even B option is working. A option worked, even B option worked for this diagram. What about C option? Let's try C option. 1 1 0. 1 1 0. 1 and 1 1. 1 and 1 1. This 0 goes over here. 1 and 0. 1 and 0 will be 0. The not of that will be 1. Okay, when C option is working, then let's see whether the last option works. 1 0 1. 1 0 1. 1 or 1 and 0. 1 and 0 is basically 0. This one comes over here. 0 and 1. 0 and 1 is a 0. Again, this is 1. I think there is some kind of printing mistake which has happened here. Maybe one of them was a OR. Yeah, I think for everyone you are getting it. I think there was a printing mistake while making this slide. Ignore that, but all 4 options work over here. All 4 options are working here. Ignore this answer slide, okay? But all 4 options worked over here, okay? Bonus question. Chalo, let's go to the other question. I think this was the actual question. Maybe what is the output Y in the following circuit when all the 3 inputs are first 0 and then they are next 1? All the inputs are first 0 and then they are next 1. Come on, what do you think is the answer for this? First they are all 0. This is 0, this is 0, this is also 0. If this C is 0, then this is also 0. 0 or, this is the OR gate. 0 or 0 is a 0. Here this is a AND first. 0 and 0 is 0. The not of that will be 1. Okay. So the first input should be 1. Can you see option A gets eliminated? Even option D gets eliminated. Either it is C or it is B. Now for the next part, if all of them are 1, 1, 1, all of them, all the 3 inputs are 1, then what will happen? If C is 1, this is also 1. 1 or 1 will be a 1. 1 or 1 will be a 1. 1 and 1 will be a 1. The not of it will be a 0. The not of it will be a 0. So I think B option is correct. This is no, sorry, not. So for 1 it is a 0. B option is correct. This option is wrong. Correct. So option B. Yes, that is the correct one. That is the correct one. Very good. B for best. B for best. Very good. Understood, guys, how to solve this question? First we took all zeros, then we took all ones. We went properly, logically we went, systematically. It was not very lengthy. Okay, let's try the next question. 2015 question. Which logic gate is represented by the following combination of the logic gates? I don't know. I have a feeling we might need De Morgan's law over here. De Morgan's law over here. If this is A, this is a NOT gate. This is a NOT gate. Even this is a NOT gate. So if this is A, this is A bar. If this is B, this is B bar. If this is A bar, B, B bar. What is this? This is a NOR gate. This is a NOR gate. Okay. So OR operation first. OR operation first. OR operation means plus. What are the inputs? A bar, B bar. Lastly, N. N means not. So you put a bar over there. Okay. De Morgan says you take those same inputs. That plus you convert it into dot. If it was a dot, you make it into a plus. That big bar that you see over here, split it into 2 small bars. Split it into 2 small bars. A bar bar A. B bar bar B. Oh, sorry, B. So A dot B, which means it is a AND gate. Which means it is a AND gate. Is it AND? Yes, let's see. D for doctor. D for doctor is the correct answer. Very good. D for Ames Delhi is also the correct answer. Very good. I think you are now getting a hang of PYQs also. And I hope you are understanding just solving NCERT is not enough also. And just doing PYQs is also not enough. You have to do both as well as other problems, the DPPs. I hope you know DPPs are there below in the description box. And Sunday's test, I hope you know The link will get activated. It will be shared with you, on Saturday night or Sunday morning. Okay, by Sunday morning you will get the link on the Telegram group. Make sure you are a part of the Telegram group, or else you will miss that test. Whole physics, chemistry, biology, all the three things. Till Sunday evening you can give it. I know Deeksha ma'am's class is there at 11 o'clock, one of the best GOC classes that you will see for IUPAC. After that, you can give the test. Don't worry about it. The link will be active till the evening night. Okay. And tomorrow you also have your, the biology class. So the output of the following circuit, NEET 2013. Come on, my dear warriors. It is very simple. I can see a NAND gate which is shorted. I can see a NAND is basically shorted. Shorted means the inputs are connected together. So when a NAND gate is shorted, it behaves like a NOT gate. It behaves like a NOT gate. Very good. Then what about this? This is nothing but a NAND gate. This is nothing but a NAND gate. And the NAND is nothing but a AND with a NOT. A NAND is a AND with a NOT. Now these two NOTs will cancel out. What is remaining? AND. AND means dot. So it will be A dot B. A dot B. D for doctor. Such tricky questions can come in NEET examination. Wow. No problem, by the way. If you are seeing the modern physics class on the JE channel also, you can watch it. No issues. Okay. Are you loving this lecture? Please let me know in the comments after the video ends. Okay, if you are watching it recorded, right now you can put up the comment. But if you are watching it live, as soon as the video ends, I am going to read all your comments. I want to see who are the sincere doctors, future doctors in this channel. I want to remember the names because I'm going to meet all of you very soon when the results come in June. Right? To get an output, one in the circuit, which inputs will be correct? Trial and error, guys. Trial and error. Just try out all the things. Don't sit and simplify the circuit or anything. Try this. Try this. Try this. Try this. Only one option will be correct. Which option is matching? Chalo. Let's see if you can solve this together, and I will only try that option. And I'll only try that option. Come on. Which option is correct? Is it A, B, C or D? Is it A, B, C or D? Check this out. Waiting for all your answers in the chats. I want output as 1. I want output as 1. Think about it. I want output as 1. That means if this is a AND gate, 100% both the inputs must be 1. So 100% C will be 1. So wherever C is 0, first of all, remove that. I think automatically all three options get eliminated. Only one option is correct. That's how I will solve in the exam. I won't even try out all the options. So that's how I will be the topper if I write the NEET exam. I'm thinking this time maybe I should actually write the NEET physics paper with all of you. But again, I have to discuss the paper immediately after, the exam is over. Within half an hour, max 1 hour, we start the live discussion session. Okay. So on this channel, you're going to have the live discussion within half an hour or 1 hour after the NEET exam is over. So that's how quick I and my team will be right after the NEET examination. Okay. Chalo, let's go ahead. I hope you understood how I did it. Okay. I did it by elimination. I know if this is 1, these both should be 1. So C should be 1. C is 0, C is 0, C is 0. Only one option like that. I don't even have to check other things. It will work out. Okay. Let's go to the next one. AIPMT 2011 question. Out of the 4 logic gates, which one is AND, which one is NAND, which one is NOT? AND, NAND and NOT. Come on. Straightforward question, my dear students. A bar bar. Where is A bar bar? Here? There is no A bar bar. There is no bar here. If you are talking about the previous question, no, the previous question did not have bar bar either. Okay, so there is no bar anywhere in these questions. Okay, what about this one? What about this one? Come on, try to answer this. AND gate, come on. AND means that D should be there. D is there over here. D is there over here, right? So it should be basically this one. The AND will be the second one, correct? So this is basically the second one over here. NAND is D with a naught. NAND is D with a naught. So I think it is the fourth option. You can see that. NOT gate is the third option. NOT gate is the third option. So 243 is there in option number D. D for doctor, 243. I don't know why the options are same. Even C option is also the same. I think there must be a printing mistake. Maybe it was not like this. Maybe it was like this. Maybe there was a printing mistake. Okay. So I'm just correcting that. Oops. See, I thought it was C. It came out to be D. If it was thought D, it would have come out to be C. So then let's change the option over here. Okay, 1 second. Let me make this as incorrect. So that when you see the slide, yeah. So both the options were the same thing. So I changed one of the option to deliberately make it wrong, and I made option C correct. Okay, cool. Chalo, let's go to the next question. The given electrical network is equivalent to NEET 2017 question. NEET 2017 question. C for Capto, D for Doctor was the previous one. So we eliminated one of them deliberately. What do you do about this? I can see some shorting happening. Over here. A NOR gate is shorted. This is OR with a NOT. So NOR inputs are connected. So shorted. So a shorted NOR gate or a NAND gate is always a NOT gate. So this is NOT. What is this? This is a NOR gate. So a NOR is a OR with a NOT. A NOR is nothing but a OR with a NOT, and this is another NOT, and this is also a NOT gate. Another NOT gate over here. Oh my God. What to do now? Don't worry. Not cancel, nullify. Nothing will happen. Only these two are there. So if only these two are there, OR and NOT will just become a NOR gate. So there is a NOR gate somewhere. Option A, I believe. Yes, it is an option A NOR gate. That's all. Crazy, right? Simplified solution. I'm not using truth tables in most of the cases. That's the beauty of my solution. That's the beauty of my teaching. I'm trying to teach you in the very easy manner, which will save you a lot of time in the exam. Many teachers will try to teach you using truth table, which is very lengthy, which I won't be doing. Right. So that completes your logic gates, and now you are a master in logic gates, and I want to check yourselves out in the DPP, which is there in the description box. And remember, mock test is there on this Sunday. So I want you guys to put it up in the comments how you loved the class, and you can say logic gates done. Logic gates done, my dear students. Yep. So as you are watching this lecture, you can see tomorrow molecular basis of inheritance, basic concepts of general organic chemistry. So these two classes tomorrow and day after. And as you are watching this video, just go down and you can see, join the Telegram for all the updates and notes. I'll share the notes on the Telegram, join it. So click on this, Vedantu NEET English. Let's make this 4,000 subscribers very soon. Cool. Awesome. And that was your NEET English Telegram. And then you also have PYQ quiz for this. Click on this. You can start your test. Yep. You can start your test. It will load. Okay. I don't want to show you all these things. Okay. This is generally on modern physics. You will get the test. General modern physics. You will have DPP. And then weekly test link is already up. Oh my God. Weekly test link is already up. I didn't expect it to be so fast, but yes, the weekly test link is up already. I was thinking it will come by maybe tomorrow. So Vedantu has a very strong and a very fast backend team. So that link is there. You will get the analysis, and yes, we'll be sharing the results. Yes, if you want to share the results, yeah, if you want, we can do that as well. So let's see whether you guys are ready to compete. It's a free test. You just have to register yourself on Vedantu, or else, a lot of spam will happen. So make sure you quickly register and create your free account and give this weekly mock test. Okay. So that was that, and we had a fun time today, my dear students. What an amazing session. You guys are now masters. Next week, how about rotation and ray optics? 111th, 112th topic. Okay. Shall we do it? rotation and ray optics, most favorite, most demanded topic by most of you. That's what I have thought. That is your Super 6 series for maximizing your marks with your amazing NEET Warriors team. Bye bye, take care, have a lovely, lovely evening, wonderful day ahead, and keep watching the classes, keep subscribed on the channel, and smash the, where is it? Yeah, it's here. Smash the like button down there. Okay, cool. Bye bye, take care, hasta la vista. Love you all.